In this video, we will do problems from study guide. And this is labeled as unit number 0, since we are reviewing algebra 1 and 2 materials. And this is second review paper and page number 15 and 16. And I'm doing some of the questions, okay? So show work on the separation of paper and attach those with the packet. Number 1, select which of the two equations represent y as a function of x and specify why the other does not. So one is function, the other is not. That's the question, right? Which is function? So let's think about putting on my calculator. This is my TI-84, and then there is a button for y equal sign, right? If it is not a function, I cannot use calculator for graphing. It must be a function. That means I can write one as the form of y equals blah, blah, blah. So let's think about solving for y. Is this first one, can you solve for y? Do you get one equation when you solve for y? Next one, can you solve for y? Y squared is 5x plus 7. And what's next step? Take square root on both sides, and we will have plus or minus square root of this expression. What do I mean? I have both cases, okay? So to draw this one, I need to use two functions on the calculator. So if I draw this, this is not going to be a function. Just like a circle. Do we have equation of a circle? Yes, we do. But when I draw this, it's not possible to draw on my TI-84 because I need to consider top part as a function and bottom part as another function. So this is not a function, and this is a function. So this is a yes function. This one, no, not a function. Okay, because we have plus part and negative part. So when we are graphing not a function, but it's a relation, and we are graphing using two equations, okay? Upper one and lower one. Next question, number 2. Given f of x, evaluate by plugging k plus 1. Oh, it's not a number. It's an expression, right? So I'm going to do it over here. So instead of x, let's plug k plus 1. So copy everything without x. Instead of x, what do I need to put? K plus 1, that's right. And now let's simplify, okay? By doing algebra, let's simplify. So first of all, let's do distributive property, 2k plus 2. Next one, I need to consider perfect square. So let's square the first, double the product, and square the last, and then expand by taking its negative, okay? So we'll do distributive property one more time. So negative k squared, negative 2k, subtract 1. And we simplify this, and we write polynomial functions in descending order. So highest power squared, and then this is canceled out. And negative 1 together, negative 2 and positive 2 all together makes nothing, right? So that's it. That is the term left. So that is the simplest form. So we are practicing how to simplify algebraic expressions with order, okay? Order of operation, power first, and then distributive property, and we add them. Question number 3. Find the domain of the function. Let's look at the denominator, okay? If I check the denominator, and there is a case we can make the denominator 0, and then there is a discontinuity at that point. However, x squared plus 1, is there any chance I can make 0 in the denominator? Would you like to solve it? Is there any number in the real number system making negative 1 when you square the expression? X will be plus or minus square root of negative 1, which is imaginary number, right? It means by using this, if I draw this parabola, this is x squared parent function, And if you add 1, this will be vertical translation, x squared plus 1. It is above 1 like that, right? At 1, it is moving up. So it never touches the x-axis. It never. So there is no case making denominator 0. So it will not be denominator 0 at all. So since x squared plus 1 is always greater than or equal to 1, there is no point making denominator 0. So domain is all real numbers, okay? Make sense? Domain is all real numbers because it never make denominator 0. So if you are graphing this on the calculator, we ends up with this graph and zoom in, zoom out. Yeah, everywhere it's continuous, right? There is no point of discontinuity on this function because denominator never gets to 0. Okay, where are we? Here. All right, next question, and I move to question number 10, and this is the notation for composition, okay? Composition with the two functions, f and g, composed. So this is a form, how we write it, and I'd like to use this as nested form. And always think about what is the first thing to do from the inside, okay? So if you take algebra 2, you remember I saying that caramel apple, this is apple input, and here's caramel, and then you put more peanuts around the caramel apple, okay? Like that. So what is the first step to do? Inside first, okay? So by looking at expression, you see f first, but f is not the first function we need to treat. We have to do g of x first, and then we will do outside last. Make sense? So let's write this given notation with the number 9, and let's use the nested form. Okay, parentheses in the parentheses like that, okay? Number 9 is the input value. Find g of 9 first, and then do f of the result again. That is composition with the two functions. So let's do first step. What is first step? G of 9, that is first thing to do. What is g of 9? When you plug 9 in the g function, 1 over 9, right? So you evaluate first the function first, step 1, g, step 2, f, okay? So you evaluate continuously with the next one, and then you can get answer. What is the next function again? F of x is 1 over x. So what do I need to do? Flip the number, right? 1 over x means reciprocal. So when you flip 1 over 9, what do you get? 9. So answer will be 9. So order is important. Which one do we do first? Inside first. Do you see inside from this notation? No. And then rewrite it, okay? Rewrite. Which one is closer from x? And g function. So you do g function first and then next one in order. So that was brief review from Algebra 2, composition with functions. Number 12. We are looking for, what is this notation for? Inverse function, okay? We use the same notation for the matrix, right? Yeah, inverse notation. So I'm looking for inverse function. So let me start writing all of this over here, okay? So let me put y instead of f of x because I'm going to say, let's exchange x and y. By swapping x and y, we can create inverse relation, okay? So that's what I'm going to do, but I noticed that there's no y. So let's replace f of x with y. And step 1, what do we do? Rewrite everything, and I want you find x and y, okay? So let's rewrite it. So y will be x, x will be y. What's next step? We will solve it. Solve for y. Solve for y. I'm not comfortable having x on the left. Can I switch left and right hand side? All right, let's switch left and right hand side. And now let's solve for y. What is first step to do? Subtract 1 from both sides. What is next step to do? Divide both sides by 2. And what is last step to do? Take plus or minus on square root 2 together, right? Take square root on both sides, and we have automatically have both of the case, plus or minus square root of everything. Can I use notation for inverse function? Yes, inverse function notation instead of y. When you graph this quadratic function, this one look like that. Add 1, so go up, and twice stretch like this. Is this a function? Yes, this is a function. How about its inverse? Its inverse is a function or not? It's not going to be a function if I don't have domain restriction. That's why we have domain restriction here. If you just think about reversing x and y, since we have two parts with the square root, it's not going to be a function. So I need to make a choice. Let's take right-hand side only for the x is greater than or equal to 0, okay? So when we flip this one, which part will consider as a function? Positive case only, okay? Because the graph look like reverse it, and that means graphically inverse is going to be a symmetrical shape along y equals x. The graph of inverse is like this. This is at 1 and this is at 1, and the graph look like this. Which one is the same part from the right hand side? It goes above, okay? Above. So I'm taking only above. So my final answer will be taking positive of the square root. That's why we are talking about domain a lot. Domain restriction is important to define its inverse as a function. Okay, so that is inverse relation. If I go with this, both of them, that fails the vertical line test, is not going to be a function. To make this inverse as a function, I need to have a restriction on the domain. That's why it is here, and I need to take only positive part for the answer. Any questions? And I'm skipping 13. I know you can do it with a calculator, so that would be easier one. Number 14, write a mathematical model for the statement y varies jointly, means together, with xn cube of z. So z to the third power, that is cube of z, right? So I need to multiply it. Varies, so I put xn z to the third power on the numerator. And inversely, because of this part, inversely, I need to put the variable w in the denominator. So we are talking about joint together means multiplication. And it varies, that means you can multiply them. And w is going to be in the denominator because it has inverse relation. Okay, so that's it. So we talk about direct proportional or indirect proportional from elementary school, and it's related to the rational functions. Okay, if we say indirect relation, it goes in the denominator, so it is like rational function. So this is parent function of a rational function. We learned that in algebra 2, but we learn only the first quadrant in elementary school as inverse relation. So inversely related, that means it is in the denominator. Question number 15. Write this equation in standard form. This is just general form, okay? So let's think about writing it as a vertex form. Vertex form, we can find the vertex quickly. So vertex form look like this. a as a coefficient and x minus h squared plus k, and h comma k, that is the location for the vertex. Have you seen this before? Yes, so we want to change the form like that, okay? How do we change it? You see perfect square in the middle? That's called complete the square. So we will do completing the square technique, SQUARE, completing the square technique to change the form. If this is multiple choice, you will graph one of the choice and given question, and you are expecting one exactly the same graph, right? If you see two different graphs, that's not the right choice. So let's see, y equals, let's take away negative so I can group only positive contents. So let's change the sign and let me put -2 here, okay? I need some number here to make this as a perfect square. So you think about what we did before, and to make perfect square, next step was take the same sign. Think about half of this number. What is half of the number 3? Yeah, we write this, half of number 3 halves, right? So that's the number I needed. So let's think about going backwards. What is the number in a perfect square? Square the first, double the product, square the last. What do you get when you square the last part? 3 times 3, 9. 2 times 2, 4. That's the number I need, okay? If I have that number, I can create this part. However, it was not there, so I need to think about subtracting that number at the same time so we can have the equal sign between the next step, okay, between the steps. I need this number, so I made it, and that means I have to subtract that number, okay? So from only this part, I can make this perfect square. So next step, and I need to move that, right? So I'm going to do distributive property. Two negatives make positive. So this will go outside from the parentheses, and then this will be with -2. I need to bring down -2 here. And next step, x minus 3 halves squared. That is the first part. And now let's calculate the second part. 9/4 subtract 2 means 8/4, right? So what's the number? 1/4. So what is the vertex? Vertex is at 3 halves, comma, 1/4, right? So what is the question? We are answering equation. So this will be my final equation. So we have perfect square in the middle by using completing the square. And I need to make this number, and I need to take that number outside to make every equation same. So you need to balance that number, okay? It was created inside. Take that number out, do all distributive property together, and simplify, and we can find the ordered pair for the vertex location. So writing this way is called the vertex form. So we talk about 3 different forms in quadratics. This is just, yeah, this is standard form, right? This is standard form, isn't it? This is standard form. And this is vertex form. And another one is intercept form. Intercept. We're talking about x-intercepts, right? That can be written as factored form. Either way is fine. Is this standard form? This is standard form, right? The equation of the parabola in vertex. This is vertex form. And this is called the standard form. And factored form is another form. Okay.